Hello and welcome back to Newman Motor Part 4. A lot has changed since last time. Had a baby in the meantime, yay! And he's healthy, so time to get back to the experiments. What we have here on the left is I've hooked up a voltmeter now to the incoming power that we're going to use to run the motor. So we have 18.29 volts on this battery at the moment. That's going to be our power source, and I've learned a couple things by watching some other videos, especially John's videos. Thank you, John, for all the good information. What I've done now is the electrons flow negative to positive, so I've actually hooked the negative of the battery to the commutator this time. Same setup as last time, except for I've just basically removed the paper clip for this experiment, so I can rev the motor slightly higher. Change the mounting. I've mounted it on a book this time instead of a block because I got too much vibration with the block. It still vibrates because my holes aren't exactly even where the rotor goes through, but the rest of the motor has not changed. We still have the neodymium magnets in here, the same as before. They're about 5 pounds a pull each, and I think there's 6 on each side. The rotor has, the shaft of the rotor has been increased to 3/8 of an inch diameter. I did that because I was attempting to tie on some stuff to this side of the shaft and make another rotor stator out to the left, but I decided not to do that after watching some of John's videos. No, this is not actually a real fork. This is a picture on the book. It looks pretty real though from this angle. No electrocution going on. Okay, so we've also got in the mix this time a bridge rectifier, which costs about $1. You can order one on eBay or you can find them online. This is called a full wave diode or a bridge rectifier. Basically what it does is it takes alternating current and turns it into DC, direct current. Now this was quite confusing to me because of the hookups, and I'll show you those in a minute. I did them wrong several times and finally got them correct. But that takes the AC voltage that the motor generates and turns it into DC voltage. Over here, the wires run to a 250 volt capacitor that we've got to store the voltage that the motor generates. It's 1,000 microfarads, and it costs about $20, I think, is what I paid for this online from Ted's. Got another multimeter over here that's going to show our output voltage or collected voltage on the capacitor, and it's set to 200 volts DC because we don't want to blow the meter. Our voltage, even off this 18 volt battery, generates pretty quickly into the capacitor. So some things you'll notice that I've done incorrectly. First of all, I don't have any insulation on any of these wire alligator clips. And that's bad. So since I don't have any, I've tried to space them as gently as possible. If you happen to touch these two, you'll short your battery, and it's useless after that. So be very careful with that. Or buy some insulators, which I have yet to do. Okay, now to the bridge rectifier. We'll talk about this for just a minute. The connections on this are actually on the corners. So there's only 2 labels on this. One says AC, you can see it here. One says AC and one says positive. And what that means is the right corner here is AC, one connector of the AC voltage, and then the opposite side, diagonal, is the other AC. This is the positive DC with the positive sign here, right under here if you can see it. Don't think we can see it. Anyway, there it is, positive DC is on that wire, and then the diagonal to that is the negative DC. So basically what you have for the connections then is you have from the front, we've got the positive of the battery goes to the starting point of the coil wire, and it runs around the bottom all the way up to the top, and then over here to the shaft. Now part of it touches the shaft at all times to make the circuit, and then I've also attached one of the leads to the rectifier at this point, and it goes down to one of the AC leads here. The other AC lead to the rectifier comes off the front of the coil wire. So basically you have one AC lead on the front of the coil and one AC lead on the back of the coil. And that'll get your AC voltage coming off the coil. The DC outputs of the rectifier go from the positive of the rectifier DC output to the positive of the capacitor, which is labeled with a plus sign. You can't see it underneath there. And then the same for the DC of the rectifier out to the DC of the capacitor. I've just tied positive and negative to the multimeter so we can see the results of that. So at the moment the system is on even though I have no switch, and my battery is still recharging here. You can see it's gone up slightly, 18.32, as we start this experiment. Now what I'll do is I'm going to have to hold my left hand to start the motor here. Get it going. And I'll look over here at input voltage. Still have about 17 or so because of the load on the battery. I mean, the load on the battery input value. And then over here on our output voltage, we're already up to 32 volts. You can see it growing as it goes here. Just in a short amount of time, we're up to 32 volts. Now it's running itself. Okay, so once again we're up to 42 volts DC right now, stored in the capacitor. It's going pretty fast. And we have the load on the input battery still around 17 or so. The motor's rotating pretty well. Now we're up to 46, almost 50 volts stored. So what I'm going to do is turn it off, and we'll discharge the capacitor. So I undid one of the nodes to the one of the links to the battery, the positive. Now you can see our input voltage is back to 0 because it's not hooked up. Go back over to our output voltage, still climbing slightly. We're at 48.8, and now it's starting to go back down because of the slight load from the multimeter. What we want to do now is we'll take a screwdriver here, and this is going to cause a fairly large spark, but just a standard old screwdriver, make sure it's insulated, and then we're going to discharge by short-circuiting the capacitor. Okay, and you can see that was a big spark, and now we're down to just over a volt. Now if we touch this again, we can zero it back out. If we get it just right here. There. So now we're zeroed back out on the capacitor. So if we go back over here and plug this back in again, okay, one last time we're at 17.3 on the input voltage, and come back over here to the motor. Now we're about 20 volts on the output, 21.